So far throughout this lesson, a number of times now, we've talked about values such as integer values and floating point values, strings as well. We've talked about variables that store values for later use, and we've talked about types a little bit also. In this section, I want to focus on the fact that every value in Python is an object, and that Python uses dynamic typing, which basically means at execution time it figures out the type of an object, and that helps it determine what that object can do and how you can interact with it. So let's go ahead and start out by just talking about the type function once again. As you've seen previously, the type function, when you give it a value in parentheses and press enter, is going to give you back the name of that object's type. So 7 is an object, and the type of that object is int. Similarly, if I go ahead and do type of the floating point number 4.1, we can see that it's a float. And since we've now done strings as well, let's do a simple string, and we can see that the type of a string is str. And by the way, that will be regardless of whether you use single quotes, double quotes, or triple quotes to delimit your strings. Now, when you create a variable, such as giving the value 7 to the variable x, the variable x is not itself an object. It refers to an object. So basically what we're saying is, for the time being, x knows where in memory the object containing the value 7 is located. So I'm going to just execute that for a moment here. So at this point, we now have a representation of what x is, and this is a logical representation of it here. We have a variable x somewhere in memory, and it's referring to or pointing to an object that contains inside of it the value 7. Objects tend to have other information associated with them as well. So for example, for most objects, you'll also have functions, which we call methods, that you can use to interact with those objects, and that's something we'll be focusing on as we proceed through subsequent lessons. All right, so at the moment, this is the representation of the variable x in memory, and the type associated with x at this point would be int, because the whole number 7 is an integer. Now, going back over to the terminal window for a moment here, we can do expressions with x like we did previously. So here we're not modifying the variable x. When we say x plus 10, we're really going to calculate 7 plus 10, which is going to result in 17. And 17 is actually a new integer object containing the value 17. But because we didn't assign it to a variable, it may or may not still exist in memory at this point. Objects that don't have variables referring to them can be what we call garbage collected. The interpreter and the Python runtime can see when objects no longer are being referred to, and then can give that memory back to the system for you. So basically, Python creates and gets rid of objects for you. You don't have to worry about that memory management as you might have to do in some older C-based languages like C and C++, and of course many of the newer languages like Java and C# and Swift, etc. have garbage collection, where they manage the giving back of the memory to the system for you. Now, to prove that x was not modified, of course, we can go back to our interpreter here and evaluate x, and we can see that x is still referring to the object containing 7. And we can also modify x using an expression that includes an assignment. So let's say we do x equals x plus 10. Now what we're saying is to create a new object which is going to be the result of x plus 10. Of course, x is currently 7, so we're going to get a new object 17, and we're going to assign that new object 17 back to the variable x. So let me go ahead and execute that statement. And just to prove to you that x is referring to a different object now, let me go ahead and evaluate x, and you can see that indeed it's 17. So as a result of snippet 7 here, what's going to happen is we're going to wind up having a new object get created in memory. I'll go ahead and create the object 17 here, and the assignment is going to take this arrow here and aim it at the new object that was just created. Now there's no arrows pointing to the object containing 7 anymore, so at this point the object containing 7 is available for garbage collection, and the Python runtime can now give that memory back to the system so that other objects can use that memory in the future. Let me switch back over to my interpreter once again, and we talked a little bit about this dynamic typing concept. So here we took x, which was originally aimed at the object containing the integer 7, and we assigned it a new integer object, so it was the same type, but you can actually change its type as well. First, let's just confirm the type of x. So we can see here that x is currently an integer, but we can assign to a variable in Python anything we want. So there's no type associated with the variable. The type is always associated with the object. So if I say to assign to x the floating point number 4.1, as a result of that particular expression, we can now check the type of x and see that it's a float. So what really happened here, if I go back to my diagram, is another object got created. Let's go ahead and make a copy here and create another object. And in this case, the object is now the value 4.1, and once again during the assignment, this arrow was aimed at a different object in memory. So these other two objects may or may not exist anymore at this point. They are at least eligible for garbage collection by the Python runtime. Now, so far we've been looking only at numbers, but just to rehash the point, we can go ahead and assign to x a string, which is of course not a numeric value, and we can confirm that the type of x is now str. And once again, what would have happened there, let me make another object here. So we'll go ahead and throw this one over here. It doesn't matter where it is, it's just someplace in memory. So this will be dog, and so at the time that we assign x, at the time that we assign x to point to the variable dog, that arrow gets aimed over at the object containing dog. So you've got 3 other objects that may or may not be in memory anymore as a result of the operations that we've done so far. But the nice thing that we're getting out of this interactive session is that we can see that the type of x always depends on what you last assigned to it.